So we're going to be simplifying radicals and higher roots. And what we mean by higher roots is that the index is no longer a square root. So if we're dealing with cubed roots, it might be helpful to write down a few cube roots to help us navigate the process. If we're dealing with fourth roots, we may wish to write down a few. Now, this gets really tricky, by the way. 3 to the power of 4 is 81. 4 to the power of 4, well, yikes, it kind of gets scary. I believe that's true. Anyways, let me move on, and power of 5, etc. We'll navigate that when we get there. Regardless, we are going to use the multiplication rule of radicals, which simply says that the nth root of a times b, we can split it up into the nth root of a times the nth root of b. Now, hopefully, the a or b is n-rootable, if that's even a word. All right, so let us continue on. So the cube root of 32. So now what we try to do is we try to split up 32 into, so it's the cube root of 32. We take a look at our perfect cubes. So which of these perfect cubes is a factor of 32? Well, in fact, it is 8. And we could write, I hope this helps. So really what we can do, though, is now I can split this up in the cube root of 8 times the cube root of 4. We know the cube root of 8 is quite simply 2 times the root of 4. And that's how it is. Very similar to what we've experienced before. Now, the only problem is that it's sometimes a little bit hard to think of a perfect cube. So right now, that's why I've written it down. Like I'm not pulling these numbers out of a hat. My brain's only so big and can hold so many numbers, and then it starts to melt. So anyways, what I'm going to try to do is I look towards my radicand and I ask myself, is there a perfect cube that is a factor of 24? And in fact, yeah. So 8. And when I see that, I can use the multiplication law to split my radicand up into 2. And the cube root of 8 is 2, right? And the cube root of 3 just remains as 3. So this is an irrational number. But now notice that. I'm just going to maybe separate this just ever so slightly because it is a common source of misunderstanding. This means 2 times the cubed root of 3. And often we write it as 2 cubed root 3. What I would like to draw your attention is that this is the index to the root. It has nothing to do with the coefficient of 2 in front. All right, fair enough. Now, 164 is kind of scary to me. Or 162 is kind of scary to me. I don't know what to say there. Should I try it out? Sure. Is 8 a factor of 162? So I'm just going to try to, no, 8's not a factor of this, right? So because 160 is 8 times 20, no, so 27. So is 27 a factor of that? And there's only a few options that I can go through here, right? So 27, so 27 plus 27 plus 27. Well, I know that 2 27s is 54. So I actually think that I could do my long division, but maybe 27 times 6? Help me out. It's kind of scary for me in the moment. So that is 42, carry the 4, 2 times 6 is 12. Thankfully, I managed to get 1. Anyways, that's kind of scary, and you sort of have to take a risk at this. So what I'm going to do, now, here's the question, how do you know? Well, one would presume that if a person's asking you questions about the cube root of 162, it is, you can simplify. So this is the cube root of 162, and I thought that I just determined that that this was 27 times 6. So now this is the cube root of 27 times the cube root, the cube root of 6. Now if you notice, my index has to be 3, because if it's not there, it implies square root. So just carrying this forward, the cube root of 27 is 3. 3 times 6, root 3. Keep in mind that these are 2 separate quantities. All right. Last but not least, I'm going to take a look, maybe not last. I'm going to take a look at f. Now f. So thankfully 32 is a very small number. And I'm dealing with the 4th root. So really what I'm going to try to do is I'm going to split up 4 into something that I can take the 4th root of. So 2 times 4 is equal to 16. Well, that is certainly helpful, is it not? So, right, so what this implies is that the 4th root of 16 is equal to 2. So when I'm taking a look at f, I can just simply write, my index is 4, the 4th root of 16 times 2. Now this is the 4th root of 16 times the 4th root of 2, and the 4th root of 16 is 2 times the 4th root of 2. And that's it. However, we do write it as 2 root 4 over 2. But we think of it like this, 2 separate